All right, so we'll continue with today's review throughout the week. But before we do, we have got a special guest from Corn Hacks, which is an annual hackathon that's held right at the beginning of every spring semester. Am I the faculty?
You might be.
I think I am.
You might be.
I'm the as of a couple years ago, I think I'm the faculty advisor for it. It's a really great opportunity, and here to tell you more about it. Go ahead.
Yeah, basically just to sum up what he said. So it's a hackathon that we have. It's going to be February 17th and 18th, so that's a few weeks after the semester starts. How this hackathon works is you get together, it's either individually or with a team of up to 4 people. You just get together for 24 hours. You can make a project. It'll be graded at the end by a panel of judges. Our theme for this year is beat the odds, because we can't legally say gambling. It's kind of along that line though. So you'll make this project. It can be really anything, doesn't have to follow the theme at all. But then it'll be graded by some judges from community businesses, professors, stuff like that. So it's a good recruitment thing as well. A lot of community businesses will see what you're doing. And then it's free to apply. You can register on the website here. It's just UNL Corn Hacks. It's free food, and then there you go, free food, and then also it's over $3,000 in prizes. So a lot of people get sent home with free stuff. So thanks, guys.
Yep. And I highly recommend it, even though you've only gone through one semester and you focused on C. It's an opportunity for you to learn something new. For example, if you just want to pick up some Java and app, what is their app development? App developer, I think it's called, and you want to just build a really quick WYSIWYG Android app or something like that. Or if you want to build a 2D game in Godot and you just want to use that as an excuse to learn some game programming or something like that, then that's a great opportunity to do it. Even if you're not going for that, that grand prize. What is it this year? Do you know?
It's probably iPads.
Okay, iPads this year. Wow. Okay. When the Switch came out, that was the grand prize. So then they had the Switch OLED one year, I think.
Yeah.
I'm not sure.
Yeah.
Anyway, iPads. You're awesome. All right. Thanks. Anyway, unlcornhacks.com for more information, and you can sign up now, individually or in teams. All right. So we can continue. I've been doing these over the weekend. In fact, I just did day 4 right before an hour ago, and they seem to be way harder than usual this year for the first few days. The first few days for Advent of Code have always been like really easy, gimme stuff. But this, especially like yesterday, day 3, or today, those are not day 3, day 4 exercises. We can come back to this and do it if we want to. But what I wanted to do first is say, let's get a taste of what your actual final exam is going to look like, or the format of the final exam is going to look like, by doing last year's final exam. Now it says part 2, because last year there was a part 1, which was a kind of a post-test survey. We won't be having that. Instead, it'll just be the programming part. Partial credit is possible because you are going to be producing several reports. You're going to be processing a large amount of data that we're going to give you, and if one report works, great. If report 2 works, great. If report 3 doesn't work and it causes your other 2 reports to completely crash, right? Get it fixed if you can, but omit it so that everything works, right? Or at least those first 2 reports work. Everything must be your own work. We can answer clarifying questions on Piazza. There won't be any help hours during the finals week, though. So let's just go ahead and get into the data that we used last year. There are these 2 weather stations, and the weather stations are taking temperature readings every so often. And then they record these temperature readings using a date time stamp, and then the degrees in Fahrenheit, Celsius, it doesn't really matter, right? What all that matters is it's a date time stamp and then a number, a floating point number, right? So the format of the file is on the first line, we give you the number of data points, in this case 5, and then each line after that is 1 data point. Now remember, there are 2 stations, so this data is being maintained by 2 different stations. They're not necessarily in any order, though. Okay. So we give you some code here. In fact, let me show you what the code looks like. That automatically processes files like that. I'll grab the input sample, the output sample, and all of the code here. And let's copy it over to the final review here. All right, there we go. There's input sample B, there's input sample A, there's what the output should look like, and then we give you some starter code here. This starter code is to relieve you of the need of doing the grunt work, basically, that you've been doing in your hacks. So if we didn't give you any starter code, I would expect that it would still be pretty easy because you could go back to your labs, you could go back to your hacks and pull code and then change it, right? For example, to represent the weather data, we've already created a data structure for you, a struct for you, that has a date timestamp as a string array, or as a string, and then a temperature as a double. Now, why did I go 17 here and make this into a static string? Let's take a look at this ISO standard right here. So if you were an American and you write down today's date, it would be what? December 12, 4 with no leading 0, 2023. You'd be wrong. If you were a European, how would you write this down? 4/12, 2023, I think. You'd also be wrong. Only computer scientists get it right. Why is this correct? Why is this the only, in fact, it's the ISO 8601, why is this the only proper way of writing down a date timestamp? Because it's lexicographically orderable, right? Imagine if it was 2016 versus 2017, and you wanted to order it. Well, the year is sufficient because the year comes first. The most significant things come first. Just like if you were to write down 1,512 versus 417, right? The most significant digit is sitting out front here on the left side. The most significant value here is sitting out front over here. Then you go to the month with leading zeros so that January 01 comes before December 10, right? Without that leading zero, how would you tell? You'd have to go in and say, okay, well, it starts with a 12, so that actually comes after 1, et cetera, et cetera. I'm going to have to split it apart into year, date, and month like we would in a structure. But using this standard, I can just use lexicographic ordering. Right? Likewise, the hour with leading zeros, colon, and then the minutes here. Okay, that's why this is the only proper way of universally representing a time. And by the way, there are other formats. For example, you could have a Greenwich mean offset. You could have microseconds or fractional seconds as well. Right? But we're only going to give it to you in this format. Okay. So why did I represent it as a string? So that I can use strcmp and not have to worry about the details of parsing it out and then comparing the year. If the years are the same, then compare the month. If the months are the same, then compare the date. No, don't mess with that. Just use strcmp. Good. We also give you a function called load data from file, right? That automatically loads up the data in this specified format up here, right? And returns an array of weather data, telling you also how many data points that it loaded up, right? We also give you a strong hint here of you're probably going to want a comparator for weather data by date and by temperature. Why? Let's take a look at the reports that we have to write. The first one is just a basic temperature report. What is the minimum temperature that the first weather station reported? In this case, negative 43 degrees. Right? What's the maximum temperature that the weather data reported? 46.5, whatever. Right? And what is the mean? Right? So the minimum and the maximum, how could I get those real easy? What if I sorted it by temperature? Where would the minimum be? Up here at the top. Where would the maximum be? Down here at the bottom. Done. Now what about the mean? I would, of course, have to go through, count them all up, sum them all up, and then divide by however many there are. I'm not going to get away from that. So if you wanted to, you could, of course, not sort it at all, and then find the minimum, find the maximum, keeping track of two temporary variables while you're computing the mean. All right. What about this second report here? And by the way, that's only worth 20 points. What about the second report? The second report is find the earliest and find the most recent. How can searching and sorting help me there? What if I were to sort it by date? Then where's the minimum? All the way up here. The maximum's all the way down here. Right? Then we have this inconsistent or missing data report. So the two weather stations, they're independent. They could be making mistakes and they're not synchronized or something, right? Report any data point in data set A, right, that is missing from data set B. So it was able to record something on 2021, but this one failed to record it. We want to know that that's missing data. It's in A, but it's not in B. Likewise, if there is anything in B that is not reported in A, right? So if there's missing data over here, that is over here. But also, is there any data point that is in A whose corresponding data point by date in B has a temperature that's off by more than 0.000 or 0.001 degrees? So for example, if you were to report this, the first data set on this particular date has a temperature recording of 32.78. But the second data set for the same date has a reporting of 32.90. Right? So they're different. There's an inconsistency there. Then there's a missing data, and whether or not it's from A or B, it doesn't really matter. On this date, that's going to be in a data set A, but it's missing from data set B. You could have another one that's missing from B, or that's in B, but missing from A. Okay? Let's take a look at the small example really quick here. There are 5 data points in A. There are 5 data points in B. If I just go back and forth, you can see some differences, right? What's one difference? That one right there. It's off by more than 0.001. Right? So we're probably going to want to report that. What else is different? That last data point. One of them is from 2001. The other one is from 2002. Right? So there's going to be missing in A and missing in B. Here's the output that we want. Right? So after we've loaded everything up, here's the minimum, here's the maximum, here's the mean, here's the earliest, most recent, and then we've got these values right here. Okay. So there's our weather, right? Let's first start by implementing those comparators as a review. Right? I want to implement the weather data by date. Right? What's my first step in a comparator? Well, first of all, is A and B weather data? No, it's what? It's void. It's something. It's what is it? I don't know. We need to force it to become the type that we expect. And in this case, we expect, let me get rid of the data files here. We expect it to be of type weather data. So it'll be const weather data star, still a pointer, x, is equal to const weather data star typecasted with A. Right? Likewise, we will want y and b. Right? Now that I've got x and y that are weather data, now I can compare them by date. Again, if you want to, you could go ahead and parse it out and here's the year, here's the month, here's the day, here's the time. Why? It's ISO 8601, the only proper way of doing it. All you have to do is return strcmp of x's date, which I labeled what? Date timestamp, and y's date timestamp. That's it. Right? What about down here, if you want to do it by temperature instead? Oh, did I? Thank you. Right. So, same thing here, right? Typecast them first. Now, here's a trick that I think I showed you, but I recommended against. Actually, I'll just return x's temperature minus y's temperature. Now, if you think about that for a second, 10 minus 5. They're out of order. 10 minus 5. That's going to be positive 5. They're out of order. They need to be swapped. 5 minus 10, right? That's going to be a negative 5. They're in order, right? Return something negative. In other words, negative 5. 10 minus 10. This is called the difference trick. That'll give you 0. What happens there, though? What's the difference between small difference between two temperatures? Like, I don't know, 5.5 and 5.6. The difference is only 0.1. What happens when you try to return that? Becomes what? 0. Tricks are for kids. Do not do the difference trick. If you were doing it for integers, it would still not work because it's susceptible to overflow. You're not going to get around writing a plain old if-else if statement. If x's temperature is less than y's temperature, then I'll return something negative. Else if, same condition here, except that I'm going to reverse the sign. There we go. And finally, the last condition is return 0. Why was I using the arrow operator throughout this entire process? Because it is a pointer to a structure. If I was not using a pointer to a structure, if it were just a plain old structure, I would use the dot operator. Right. Okay, there we go. All right, that's done. Now let's take a look at the weather reports. We also gave you a bunch of code to actually load up dataset A and dataset B using command line arguments. So you're going to want to give it the first file and the second file, and if you don't give those the proper files, then we exit on you. Note here that you could have a different number of data points. In the first file, you could have 10. In the second file, you could have 9 because one of them is missing. So we're keeping track of the size of each of those in separate variables, n and m. We're keeping track of the data sets as dataset A and dataset B. If for whatever reason that fails, then we quit out of the program. That file didn't exist or something. Right? We also free it for you down here. Why? Because we want you to run Valgrind, and we don't want you to have a bunch of red herrings as to data or memory leaks. Okay. So generate these reports. Let's come back up to the top here. First thing to do if you want to generate this report is to do what? If you want to report the minimum and the maximum with respect to temperature, I want to first what? Report 1, temperature. I did it right. Temperature. So step 1 is to sort it. How? Qsort. What are you sorting? Data set A. How many things are in data set A? N. What's the third argument to qsort? Size of the number of bytes that it takes. Am I sorting an array of integers? No. Am I sorting an array of doubles? No. What am I sorting? An array of weather data. And finally, which comparator do you want to use? What did I have over here? By temperature? Yeah, can get rid of this. By temperature. Right. This is just for formatting, so printf. I'll just steal that directly from the handout. Right. There we go. And printf, nice formatted ASCII separator there. Yay. Printf. Now, the minimum is going to be %f and the line. What's the minimum? What's the mean? Printf. Mean %f and the line. Mean and printf max %f and the line. Oops. And the line and max. How do I actually get those values after I've sorted it? Double min. Where's the minimum going to be? Right at the top. So data set of A sub 0. Now, how do I get the temperature on that? Is it going to be the arrow operator or the dot operator to get the temperature? So what is data set A again? It's a pointer to a data structure, to a struct, right? But when I get one of them, is it a pointer anymore? It's a regular old structure. So if you have a regular old structure, the dot operator will do. If you wanted to, you could of course put an ampersand in front of it, make it become a pointer, and then use the arrow operator. Why? Just use the dot operator. All right. What about the max? Where's that going to be? Is it going to be at n? -1. Why? Because it's always in zero indexing. What about the mean? Yeah, we have to. No, we're not going to get by this, right? So for int I equals 0, I is less than n, I plus plus, your basic idiomatic for loop, right? I need a total that I will initialize to 0 here. For, I already did that. Total plus equals data sets of I dot temperature, the ith temperature. And then at the end, the mean is going to be the total divided by n. Is there an integer truncation issue there? One of these has to be a double, right? And one of them is. This is an integer, but this is not an integer. We're still good, right? Let's go ahead and compile everything and at least make sure that I didn't make a mistake here. Weather.c and weather reports.c. Yeah, it worked. Or at least it ran. And I need to provide it the files. We provided this input sample file here, input sample A and input sample B. Right, there we go. And we got that as a result. Let's open those up. Remember, I'm only processing this file so far. That certainly looks like the minimum to me. That certainly looks like the maximum. And then you pull out your calculator, you can add up 5 things, right? And see if that indeed is the mean. I believe it is. Right. Okay. Good. We just got, what is it, 20 points? Let's go ahead and get 15 points now. Right. For the data in set A, report the earliest possible by date, a data point, and the most recent possible by date. It should look something like the following. So once again, I'm going to go ahead and steal this. Right. And you know what? I'm getting tired of, what do I want to say? I'm getting tired of copying and all that stuff. Let's do something like this. Printf. There we go. Magic. All right. I'll tell you how to do that in a second here. We'll get that and that. All right. What I just did was block selection mode. Right? Block selection mode is supported in most IDEs. You know, this is just regular selection mode, line selection mode, that if you drag your mouse somewhere, it's going to select it because that's how text works, right? But of course, you know, we're not texters, we are coders. And often things are blocked and you want to either select a block or do something with a block. And so what you can do is go into block selection mode. And you can select from one column over to another column for any number of lines. Now this is a rectangle selection mode, whatever it's called. It's a block, right? If you select a block and you start typing, oops, let me start here and then go to here, then whatever you're doing is repeated on all of those lines. You can also likewise delete things. You can cut and paste things like this. Now on online VS Code IDE for Mac, don't quote me on Windows, I don't know what it is. It's going to be hold down the Shift button and the Option button. So start wherever you want to go, then Shift, Option, hold it down, and then select what you want. Yeah? For Windows, it's Alt-Shift. Right? That makes sense because Alt is the option of Windows, right? If we're using Eclipse, then you can go into like it's Alt, Shift, Command A to go in, and then you can go back and forth between it. Right? Okay, magic, neat. Back to actually doing it. Right? Remember that I need to sort it by date. Right? So let's sort it by date. Qsort, and I'm just going to steal what I already wrote here. Copy, paste. Don't get into the habit of that. But copy, paste, dataset A and weather data. The only difference that I make is what? Instead of by temperature, it's by date. Right? In fact, I'm even going to steal these. No, I don't want to steal those. Right? Instead, what I'll do is I'll format the, should it look like? It's the temperature and then the date. So the temperature is going to be %F, and then the date is going to be %S and %S. I could have saved some typing there between block selection mode, but it was just 2 lines. Right? And that's going to be data set A sub 0 dot temperature and data set A sub 0 dot, what is it called? Date time stamp. There we go. all over again, but not for, oh, not I. What should it be? 0 and minus 1, 0 and minus 1. Once again, compile it, run it. The earliest is going to be in 2017. The latest is in 2022. Let's double check that. 2017 looks like the earliest to me. 2022 looks like the oldest to me, or the most recent to me. Not oldest, most recent, newest. Right. All right. We got ourselves 15 points. Now we need to do some inconsistent data checking. Again, we're going to want to iterate over everything in A and check to see if it's in B. So let's outline this. Right? Let's whiteboard this, except that I'm not on a whiteboard here. I'm on my actual code here. So I'm going to outline it with pseudocode. For each data point in A, find the data point in by date in B. Right? If it here, I'll put it at the same side here. If it does not exist, report what? Missing data. Otherwise, if it exists, but the temps differ, then report inconsistent data. Otherwise, do nothing, right? We don't want you to report, because the way that this actually worked that year is we gave 2 files that were 10 million lines. So they were 50 megs or so, maybe more. Right? No, we gave ones that were 1 million lines, and then on the server we put 10 million lines. The reason that we wanted you to do that is because, or we did that with such large data, is if you do this in a naive way, it ain't executing. If you do this in the naive way of, for each element over here, right, here's one element. There are 10 million elements over here. If you use linear search to go through 10 million elements, that's 1, 2, 3, 4 times 10 million. If there are 10 million over here, 10 million times 10 million, how big is that? 100 trillion. Right? Are you going to be doing 100 trillion operations? Yeah, but not anytime soon. Right? So what you need to do is, for each element over here, how do I search efficiently over here? Not linear search, but binary search. So if everything is identified by a date, right, then I need to sort it by date. In fact, I need to sort both of these by dates. Okay? So let's come back over here and do that first. By the way, A is already sorted by dates because I didn't mess with it afterwards. So now let's sort B first. All right, sort B now. ... The only difference is you're sorting data set B. There are M of those, and then you're still sorting it by the date. Okay? Now, you can get clever. Clever code is rarely the way that you want to go, though. Clever, right? So one clever way of doing this would be to sort both of these by dates. Then if the data is perfect, they should match up, right? Well, that all works until it doesn't, right? So these two match, these two match, these two match, these two match. Uh-oh, this one is missing from over here, right? Now what do you have to do? You have to report that, but then you move on with this one, but what about this one over here? You don't move on because this one still has to be searched for over here, right? If there's missing data, these two fingers are going to be very, very off very, very quickly, right? And you can do it. You just have to be extremely clever about it. I don't want to have to worry about that. In computer science 2, one of the quotes that I give for a mantra of the course or a theme of the course is data structures and algorithms, or dumb code and smart data structures are a lot better than the other way around, right? What that means is use smart data structures and dumb code, just straightforward, simple code, right? All the power is in the data structure, or in this case, the algorithm, the sorting algorithm, and exploiting it using binary search. Using this and making sure that these two things are don't get out of sync, right? That would require a lot of clever code, a lot of smart code, right? That's not as good as dumb code that's straightforward and it's and easy, right? Keep things easy, right? So for each point in data set A, that's just a simple for loop. For int I equals 0, I is less than n, I plus plus, right? Find the data point in B. Now that they're sorted, how should I find a data point in B? I'll just call it, what, B? Hint, B. How am I going to search for it? What kind of searching do you want to do? Did I say, I told you already that linear search ain't going to cut it. Right? Binary search, and the function for that is B search. Right? B search requires almost exactly the same up here, except that it has a key first. Right? You are searching data set B, which is of size M. Each one of them is of size weather data, and you're going to be using the exact same comparator that you used to sort it. If you used a different comparator, right, then you are comparing apples to oranges, right? Oranges to apples. You have to make sure that you are sorting by the same comparator. Okay? Now, what's my key in this case? What's my needle that I'm searching for? The key is the data in A, data point in A, right? That is data set A sub I. There. If I try to compile this, it'll give me a warning. GCC, right? Right there. Once again, data set A, what is it? It is a structure pointer. So when I get one of them, either 0 or n-1 or I, right? Then it is a regular old data structure, or structure, excuse me, right? So this requires a pointer to a structure. So I went from a pointer down to a regular structure. I need to go back to a pointer. What do I put in front of it? Ampersand. Right? Now, is it guaranteed to exist? No. In fact, if it does not exist, report the missing data. So how do I check for that? If missing. Right? How do I check to see if it was a successful search or not? An unsuccessful search. What will it return if it's unsuccessful? Null. Right? What were you supposed to report? Missing data, something like this. There we go. Missing. So printf, missing data, and I'm going to steal this code right here and adapt it. Some room. There we go. I and I. Because that's what I am searching for right here. Right? All right. Else if. Now we need to, we found it, but we need to make sure that it's not inconsistent. How is it not inconsistent? So I'll report that here. Right? Let me try this first of all. Let's give myself some space here. I'm going to go ahead and get the temperature in dataset A. So dataset A sub I dot temperature. Right? And if that's not equal to this guy right here, B's temperature, then I'll report inconsistent data. Now, obviously, that was not real code there, right? Why am I using the dot operator right here? Because it's a regular old structure. But is B a regular old structure? Nope, it is a pointer to a structure. So what do I use to get its temperature? An arrow. Is that safe? Yes, because it's not null. I wouldn't be here if it were null, right? But is it safe to use this not equals when you're dealing with floating point numbers? No, we've already seen that many times over. When we did testing with respect to, say, floating point numbers, you passed the test if it was close enough. If it was to within 0.0001 or 001 degrees, right? So I'm only going to report it if the difference between those things is greater than 0.001. Right? Careful. Right? What's going to happen with something that's like way off or something? You can't just do the difference. What do you need to do in front of it? Absolute value. Is that correct, though? Abs is for integers. Are these integers? Nope. So what do you need for floating point numbers? You need fabs. Fabs abs. Right? All right, good. And once again, I'm going to steal this. This is percent. Actually, no, I'll type this out. %f versus %f, and then they both have the same date, otherwise I wouldn't be here, right? End the line. And so I'll say data set A, temperature, B's temperature, and then data set A or B, it doesn't matter because they're the same date. It's date timestamp. There we go. And is that good practice? Down here I said, in my outline I said, else do nothing. Should you have dead code like that? No. Get rid of it. Get rid of the cruft. And now that I'm done with my outline, I'm going to get rid of all my crufty comments here too. Oh, I should have made sure that it works first, right? Darn it. Somebody point out that I didn't have a end of that line. Okay, there, that was it. Oops. My two samples there. There we go. Inconsistent data. We saw that inconsistent data. Remember that it was 1.97 here negative and 1.96 over here. All right. Missing data. It's missing from 2022, right? 2022 is indeed missing over here. But what else can you say? 2021, do you see that in the first sample? Nope. So back to the drawing board. I'm doing this for each element in point A. What if there's something in B that's missing from A? What do I need to do now? All of this again, but for each point in B. Remember that there are M elements in B. I'm going to call this A instead, and I'm going to take B, A, and M goes to N. Same by weather date. If A is null, then it's missing. Do I need to do this again though? So if there's a data point over here and a data point over here that they disagree, it's going to be reported from one end. Do I need to report it again from this end? Nope. Don't need that at all then. All right. And now I'm getting that missing from, oops, sorry, I should probably change this to B's then, right? Oh, what? Oh, yeah. This should be B. There we go. Should that be B as well? It doesn't matter because they'll be the same, right? I don't know. Let's run it and find out. Okay, there we go. We got it now. All right. So it's missing 2021 and 2024, but 21. If you wanted to, we could go back and missing in A from B. Right? We could add more verbose comments here, but it doesn't matter. We did not use code post last year, and so this year, when we give you the starter code, unfortunately we're gonna have to dictate and give you code to do all the formatting, just like we did in we're doing in Hack 13. All right. That was it. Right. Now I don't have all the data from last year, but again, there were millions of data points. If you did this in a naive way and did every single pair 10 million, 10 million, that's 100 trillion operations. That's not going to be executing. I think there was a time limit of 5 minutes. It'd be executing in hours or days or something like that. Okay. But this is instantaneous because there are only 5 points, right? I think on the 10 million, it still took like maybe 30 seconds, right? But at least it was only 30 seconds. Okay. All right. Let's see. Well, we got 10 minutes left here. I already showed you the block trick. So there's really no reason to go back to Advent of Code today. I was going to show you the block trick with Advent of Code. So today is the 4th? Yeah, today is, which opened up at 11 o'clock last night, looks something like this. So you've got these lotto cards for the pickle cards or something like that. And these are the winning numbers, and these are your numbers. And basically what you have to do is for each card, you have to go through and figure out how many winning numbers you had. So for example, card 1 has 5 winning numbers. 41, 48, dot, 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 through 17, and 8 numbers that you got right there that came up in your pickle card. And 4 of them were winners, right? Here's 48. That was a winning number. What else? 83. That was a winning number. And 17 was a winning number. And 86 was a winning number right there and right there. So for each card, what you have to do is you have to go through your numbers and determine how many of them appear in this first set over here. Once you do that, then you can compute a score. For the first match, you get 1 point. Then it doubles for each one. Since we have 4 winning numbers right here, 1 doubled, 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 right? The first one gives you 1 point, the second one, the third one, the fourth one. So it's worth 8 points right here, right? And the second part is a little bit harder, but the real difficulty here is in processing this data. Right? Now, if you were to actually do this in C, how would you go about doing it? I would go back to Hack 10, pull out my code for reading every single line from a file, right? Cut and paste that and put that into a text file. Let's see, new file, input.txt. Put that over here. Come on, there we go. And what I would do is I would get each line. Now, for each line, how are you going to process that? How do you process a line of data if it were CSV? Right? If there were a bunch of commas, what would you do? tokenize with a bunch of commas. It's not separated by commas. It's separated by spaces. You would ignore the first one. You would ignore the second one. The third one is where you would start reading those numbers. So 1, 2, and all of them have 5 numbers here. Right? Now, the real data is different. Where is the real data? Here's my input, right? It has 209 cards, and each one has, I think, 10 winning numbers, and then you have 25 numbers or something like that. You could still hard code those values, right? But you would have to write different code to do it, right? Okay, I don't like doing that, right? Now that I know the magic of block selection mode, what could I do? Winning numbers, nums, there we go. I want an array of arrays, right? How many of them are here? 1, 2, 3, 6 lines. Each one of them has 1, 2, 3, 4, 5 things in it. So it's a 2-dimensional array of integers. Each one of those could be an array. So 41, 48, 83, 86, and 17. I'm already tired of typing. Right? What could I do instead? Oops. Start here. Copy. Paste that. Right? There. It's still not in the format. What do I need to do now? Let's get rid of this for a second. It's no longer input.txt. It's input.c or h, whatever you want. Right? So it's not syntax highlighting. Let me undo this. Let me create a new one. New file. AOC input. Dot. Let's go with H, so that syntax highlights it. Bring it over here. There we go. Now what do I need to do to make it actually, syntactically correct? There we go. There's the first one, and then commas right here. Block selection mode, comma. In fact, I'm just going to go ahead and cut and paste that. Oops. Now I've got to go back into block selection mode and paste it. Yeah. Oh, arrow over? What do you mean? Oh. Yep. Okay. So comma, comma. There we go. Nice tip. And then like that. And now I've got it in a manner that I don't even need to write any file I/O. Right? But I wanted to use this as one last opportunity to show you another way of doing this. And again, it's magic once you've learned it. I want commas between all that stuff. Find and replace. Right? I want to find every single number separated by a space, And I want to replace that with the number itself and then a comma. Okay? I don't want to have to do arrow over 5 times. Or when I get to the actual input here, I didn't have to having to do it 10 times and then 25 times. I hate typing. So I think I mentioned it before, but I didn't really mention, I didn't have a good example for how this can save your life, right? 0, I want to use what's called a regular expression, right? Square brackets here is what's called it's not a grouping, it is well, in this case, it's a range, right? So any numbers 0 through 9, if you wanted it capital A through Z, right, you could do like that. Lowercase a through Z, right? A through Z, or a combination of all of those things. That's a regular expression. Obviously, there are no letters in this file, so it's not finding anything. So let me go back to 0 through 9. 0 through 9. That's matching anything. What I want to do is I want to match 1 or more. And do you see what happened there? It was kind of difficult to see maybe up there, but now it is only matching like 41. It also matches 1 because this is 1 or more numbers. Right? Now what I can do is I can group that. Right? And I can replace it. Replace the first match with itself, the first match, and a comma right after it, and then a space. Or no, I don't need a space because spaces are already there. Do it for all of them. All right. Done. All right. This is how people get on the leaderboards, by the way. They know their regular expressions back and forth. And they can go ahead and get it into this form almost immediately. Right? If you want to, I need a curly bracket at the beginning of every line. Right? Then I need to replace that with this and do it for all of them. Right? Unfortunately, I shouldn't have had those blank lines. Right? But that's okay because I can come back and remove those. Also, at the end of each line, I need to replace that with a bracket, or sorry, the end of each line with a closing bracket and then a comma to go down to the next line. Did that. And once again, I shouldn't have those blank lines there. Right? And then there is a superfluous one here, right here. I don't know that would compile, or I probably would not compile, but that's okay. I can get rid of that with block selection mode. Right? So that's how you be a competitive programmer. You know all of these little tricks like block selection mode, like regular expressions, et cetera, et cetera. And now it's what? Int winning nums of how many were there? 6 and 5. There we go. And is equal to, and then this entire thing, and then close it off there, and I'm done. I've got my input without having to do anything special. Right? Do the same thing for this. Block selection mode on 200 lines. Now I'm going to use a regular expression. Right? And then you can get real fancy and do things like, I don't know, sort the input sample A. There we go. Tell me about that sorting right there. If we did not have that first line, guess what? It's sorted by the first column there. If you wanted to, you could use another tool called awk. Awk, to separate things and start formatting them. For example, you can use printf style formatting here. I think this is the way to do it. Printf, %f, %s, and then comma percent or $1, $2 of input sample A. Whether or not this works, I'm crossing my fingers, and this one probably won't. No. Okay, darn it. Printf, we'll just do it like this. If I wanted to move those 2 columns around, for example, I wanted it reversed. Oh, did I didn't forget that. There we go. End the line. Print. Not printf, but there we go. Oh, and then I want a space, right? So I do want printf. Printf, $2, space, end the line, $. There. No, that's not getting me either. Darn it. I forget the syntax for doing this, but you do see that it was that it was reversed here, that I was able to put the temperature first, right? So if you've got data to massage into a format that you want, you can send it through various tools like this, awk, grep, which is a regular expression, find regular expression, stuff up here, right? So tips and tricks like this, you'll pick up as you go along, and you'll get so much faster that you'll be able to make the leaderboards eventually too. All right, we'll continue next time.